Alrighty, let's do some examples. We have our three formulas up here that we're going to be using, and they're also in all the questions. And the parts of our formula are also listed. The weird looking symbol is wavelength, F for frequency, E for energy, C is our speed of light, that's going to be 3 times 10 to the 8, and H is our Planck's constant, that's going to be 6.63 times 10 to the minus 34. So let's look at this first example. It says right now we're releasing light. The frequency of light released by humans is 3.2 times 10 to the 13 hertz, and we want to know what is the wavelength. So they tell us what the frequency is, and they want to know what's the wavelength. So we need a formula that has both F for frequency and lambda for wavelength. And it looks like it's this one, because that has my F, it has my lambda, and C is a constant. I know what the C is. So we'll fill this in. C is 3 times 10 to the 8. Wavelength we don't know, but we do know that the frequency is 3.2 times 10 to the 13. So now if I want lambda by itself, we have to divide. So if you find it difficult to plug things like this in the calculator, you can figure them out by hand. So the numbers we can treat just like normal. So I'm going to do 3 divided by 3.2, which gives me 0.9375. So these exponents right here, these guys, because we're dividing, we can subtract them, and that'll give me my new exponent. So whenever you have exponents that are dividing, you can subtract them. So we do 8 minus 13. And if I do 8 minus 13, we get negative 5. So that would be 10 to the negative 5. So if you wanted to move this over one, we do 9.375 times 10 to the minus 6, because we moved it one more time to the right. And if you plug it in the calculator, if you plug all of this in the calculator, you'll get the same thing. But the moral of the story of what we're getting at here is that you look for the formula that has both the variables that you're looking for. So like in this next example, they tell us the wavelength of the gamma ray that hit the Hulk was about 3.3 times 10 to the 14 meters, and we want to know what's the energy of that wave. So they give us wavelength, so we need something that has wavelength and energy. So this one doesn't have energy in it, so I can't use that one. This one doesn't have wavelength in it, so I can't use that one. So it's got to be this one, because it has both the energy and the wavelength. So we have E is equal to HC divided by our wavelength. So we'll plug in H, which is 6.63 times 10 to the minus 34. We can plug in C, which is 3 times 10 to the 8. And I got both of those numbers from our two constants, 3.3 times 10 to the 8 and 6.63 times 10 to the minus 34. And so then we're going to divide by the number that they gave us, the wavelength. So 3.3 times 10 to the minus 14. So what I'm going to do, if I'm going to calculate this manually, I'm going to multiply this and this, and then divide by 3.3. So if I do 6.63 times 3, I get 19.89. If I divide that by 3.3, I get 6.027, and then 27, 27, 27 repeats. So now let's deal with the exponents. So we'll have times 10 to the something. We don't know yet. So our exponents are right here. So these two are multiplying, so we're going to add them. So we'll do minus 34 plus 8. However, because the 14 is on the bottom, we're going to have to subtract off 14 from that. So when we do minus 34 plus 8 minus 14, we get 12, negative 12 exactly. So I'm going to put negative 12 right there. So our energy that we calculated is 6.02 times 10 to the minus 12, probably joules. But the units aren't as important in this lesson as it is being able to plug things into the formula and calculate it out. So let's do another one. A photon in TNT explosion might carry 1.32 times 10 to the minus 18 joules of energy, and we want to know the frequency. So they give us the energy, they want the frequency. So we need a formula that has both energy and frequency. So that looks like this one. So they tell us the energy is 1.32 times 10 to the minus 18 joules. We know that H is a constant, so we know that. 6.63 times 10 to the minus 34. But we don't know F. That's what they didn't tell us. So now, because we're multiplying on this side, we're going to divide by our Planck's constant, so that we can have F by itself. So if I calculate this manually, I'm going to put 1.32 divided by 6.63, which gives me 0.199. And so our exponents are on top of each other. So I'm going to do minus 18 minus 34, which gives me 16. So this would be times 10 to the 16. If you want to move it over one, we can say 1.9 times 10 to the 15, because it's a slightly different number. However, most of your answers you should be able to find just by working out this first number. I think we have two more to talk about. So in this one, they want to know the energy given the frequency. So we have frequency and we want energy. So we need a formula that has both frequency and energy. So which one has E and F? This one. So now we don't know the energy. We know that H is 6.63 times 10 to the minus 34. And we know that F is 7.5 times 10 to the 8. So I'm going to multiply these two numbers like normal. 6.63 times 7.5. We get 49.725. So because these two exponents are next to each other, they're multiplying, we're going to do 34 plus 8. Negative 34 plus 8. Which gives us times 10 to the minus 26. We move that over one. 4.9725 times 10 to the minus 25. Again, most of your answers you can find just by working out the first number, but you should know how to work out the exponents. And again, if it is too difficult to calculate it by hand, you're more than welcome to just plug it into the calculator if that's easier. All right, last one. UV rays that give us sunburn have as much wavelength as 3 times 10 to the 7 minus 7 meters, and we want to know the energy. So they tell us the wavelength, and we want the energy. So we need a formula that has both wavelength and energy. So it's definitely not this one, and that doesn't have wavelength, so it's not that one. So it has to be this one. So E we don't know, but we know H, 6.63 times 10 to the minus 34. We know C, 3 times 10 to the 8. And we know lambda, because they told us the wavelength is 3 times 10 to the 7. So again, you can plug all of this in, but I'm going to let you know anytime you have a number divided by itself, like this 3 right here, it's just going to cancel. So our bottom number is going to be 6.63. It's an ugly 3. So now, again, we have this kind of weird dynamic with our exponents. These two are multiplying. So I'm going to do minus 34 plus 8, because those two are multiplying, and whenever we multiply, we add the exponents. And then we'll do minus 7. That's a minus 7 there. So if I do negative 34 plus 8 minus 7, we get times 10 to the minus 19. And so that's our energy given this wavelength. So we're going to do a couple more practice problems in class, but I wanted to show you some examples of figuring out what formula to use and how to plug them all in.